Morning is 6. Welcome to Maths for this term. This is the final maths lesson, and it concludes our sequence on area, perimeter and volume. So prepare your page in your book. Please do use your book. Some of you are still writing on the sheet, and that's going to be quite hard for you to add to your portfolio of learning. I'm very hopeful that we'll be back sooner rather than later, and then you can bring your books in and we can review your learning. Remember, there is a lot of new learning in this unit, and perhaps for many of you, particularly in the volume, therefore give yourself the time to learn and to practice these skills. The beauty of the video is that you can just kind of come back to it, pause it, rewind it, take a break, come back. It's a great tool, I think, you have here. But if you do need help, please ask. If you can do that via Class Dojo, because it's very straightforward for us to set up some support meetings, which we have done on many occasions. Please definitely post an example of your maths on Class Dojo. Many of you are doing a great job. You're doing it every day. Unfortunately, there are a few who are inconsistent, and when we're reviewing your portfolios and checking your progress, it's really noticeable. So if you're not doing that because you need help, then ask for help. Otherwise, please do post your examples of your work. The volume of each cube is 1 centimeter cube. By that we mean these small individual ones. What is the volume of each shape? 3 shapes. Pause the video and have a go. So let's have a think and see how you got on. This is how I would do it. We've got 4 there and 3 in the layer. So I would do 3 times 4 is 12. I always think it could be slightly embarrassing if I get this wrong. But if I do, it could be that I'm just trying to check if you're listening. Who knows? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I am checking on everyone who's listening. 8. How many times 8? 3 times 8. 3 times 8 is 24. Poppy's been doing well on learning the times tables during the remote learning. How is everyone getting on with the ultimate? Get practicing. It's going to help with these things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 3. 3 layers. 30. What did the question say? What's the volume? So I'm not quite right yet, am I? You need to do centimeters cubed. Let's do it in pen. Just so Yasmin and Yasmin's mum can enjoy that. I'm not going to do the others, but you need to put it in. Thanks, Yasmin. Right, let's move on. 12. Phew. 24. Phew. 30. Phew. Got that. Did you? Just because you can't see the ones behind. So that, if you take on these, and these are all cuboids. So if you take the one layer, count them, and then multiply it by how many you've got in the stack there. So let's move on. There we go. Who had the Rubik's Cube? Johnny. Rubik's Cube. Invented 1974. Manufactured in the UK 1980. My goodness, that's like history to you guys, isn't it? I deny I was there. Too young. There we go. 1. That's the cross section. Let's take it out. That's what we've got. 3 cubes, 3 cubes. 3 threes are 9. What we're going to do now, because how many were there in the stack? We probably should be talking about lengths and widths and heights. Let's put these together. Rubik's Cubes, colours as well. Some of them. This one. Put that on. Put that one on. 9 cubes. How many red cubes? Yeah, Evelyn's got that. That's 9. What about how many, Josh, how many blue cubes? 9. Yeah. And let's go for a times table. Let's go to Kyle. How are you getting on with your times tables? How many? We got 9 and we got 3 lots of 9. 27 cubes. So what's the volume? Emma Roach, what would the units have to be? Correct. Length, width, height. Which is which? Well, the dimensions here are all the same, aren't they? It depends which way. It kind of depends which way you're looking at it. If this was head on, then that would be the length, and that would be the height, and that would be the width. If you were looking that way, that would be the length, that would be the width, and that would be the height. It depends which way you're looking at it. I might want to pause there and just, we've talked about this before, what's it like getting these 3-dimensional shapes into your mind? You could create that. I saw some lovely practical learning from Will. He'd made volumes out of some cubes he had. Nice one, Will. What we got here? Now we don't seem to have the individual cubes, but we do have a formula now, don't we? So we've got length multiplied by width multiplied by height. Is that going to help us? Now, the good thing is, it doesn't matter which order you do that. Have a go and see what you can find out. Okay, there we go. 5 times 3. 5 times 3. Who can give? Yeah, Elena, 15. Nice. So 15, and then we have 2. What's the answer to that? Yasmin, 30. Yeah. Now, if we got centimeters, centimeters, and centimeters, centimeters to the power of 3, centimeters cubed. just get rid of my annotations. 30 centimeters cubed. 2 3s are 6, 6 5s, 5 times 3, 15, 30, 2 5s are 10, multiplied by 3. So actually, you know, that you can do these in any order. Yeah, well, Tom, commutative. Commutative. Thank you. And there we go. There's the centimeters to the power of 3. Just as if you were doing a cube number, one number multiplied by another number multiplied by another number, which you did in arithmetic on Fluency Friday. So have a think about these. Use the formula to calculate the volume of the cuboids. And I'm really starting to think now on reflection as we go through this, is really the most difficult bit, I think, is remembering this when you haven't done it for a while. But, you know, in the moment, it's fairly straightforward. So do your best, fingers crossed, pause the video, show all your workings out, please. Meters cubed on that one. Millimeters cubed. Okay, have a think. Is that what you got? Did you get something else? If you did, why? Multiplying the 3 numbers. I guess, you know, that when they're on there for you, it makes it fairly straightforward. What would be fascinating is if one of them was missing. Let's do checkpoint. The area of the green square is 25 centimeters squared. Remember that area? So this is this green area, and that was one side multiplied by the other. So the volume of the shape is 100 centimeters cubed. The volume of the shape is 100 centimeters cubed. Shape must be a cube. Okay, false. If the shape was a cube, the volume would be 125 centimeters cubed, not 100. So it must be a cuboid. I suggest you pause and have a think about that. So we go at questions 1 to 4 on the worksheets. I'll post those on Class Dojo. Use the mark scheme to self-assess, and if you can do ticks and dots, and if you dot, correct them. It is quite hard for me to see them on the pictures, particularly Harry's pictures. Harry, nice close-ups, please. But where I can see it, it gives me a good indication of how you're getting on. So the ways I know how you're getting on really are, if I can see the picture clear enough to get an impression, and whether you do or don't contact. So if you don't contact me because you're feeling like, I don't know, you know, a little bit shy to do it, I'm going to only assume that you're getting on fine. So it'd be really great to start being brave and saying this is the last week of term. And as I say, I'm very hopeful that, you know, schools will start reopening in March. And I think, you know, that if you've been giving all this learning a great go, you're going to come back, you know, full of learning steam. So, you know, please let me know if you're getting on fine. Brilliant. Okay, so before we move on, the volume is 1500 centimeters cubed. The volume is 150,000 centimeters cubed. Who do you agree with? So the implication is one of them is right. What mistake has been made? Here we go. The formula: length times width times height. Just before we move on, just double check. So we've got meters, meters, centimeters. Look at this. Both the answers are in centimeters. So you could change that to meters, work it out, and then do the conversion to centimeters. Or 100 centimeters. What's 3/4 of 100? Because if you were going to do the conversion here, how many centimeters is that? So last chance, who was correct? So we got the 20, the 75. Do you agree with the 75? That looks reasonable. 1. That was 1 meter. 100 centimeters, 20 centimeters, 75 centimeters. Just to be clear. Actually, was not sure we know her name. She was correct. So if a cuboid has a volume of 20 centimeters cubed, what could be the length, width, and the height? Have a think. One option, 2 options, multiple options. There's the formula. That's what you're trying to get to. So 3 numbers multiplied together that make 20. Shape's made up of 2 different size cuboids. Calculate the total volume of the shape. So do this one and then this one. Pause the video and have a think. So have a go at the rest of the questions. Excellent. Great work, Year 6. Let me know if there's any help you need. Otherwise, see you next time. Take care.